Hello everyone, welcome to another episode of Deep Dive Knowledge Talk. Welcome. So tonight we explore how integrating knowledge graphs with LLMs tackles their reasoning and factual accuracy challenges. Discover how this bidirectional approach enhances robustness, reduces hallucination, and builds trustworthy, responsible AI for critical applications. So, how do large language models currently handle reasoning and factual accuracy? And so what are some of the limitations that have been identified in their performance?
Large language models or LLMs are like very smart parrots that can repeat and generate text. They're really great at putting words together in a way that sounds good, but they have some important weaknesses. One major issue is that these models learn by predicting what comes next in a sentence based on surrounding words, much like guessing what a friend might say next in a conversation. However, this doesn't mean they truly understand the meaning behind the words. As a result, while they can create sentences that sound really fluent, they struggle with reasoning and making inferences based on real-world facts. To help with this, a new approach involves using knowledge graphs, which are like maps that show how different pieces of information are connected. So, by using these structured maps, the models can improve their reasoning abilities and ensure they're more so accurate when it comes to factual information. This method helps the models become more reliable and consistent in their responses. In summary, while LLMs are really good at generating text, their lack of deep understanding and reasoning based on facts limits their performance. The use of knowledge graphs can help overcome some of these limitations.
What specific advantages does the proposed framework offer in terms of integrating knowledge graphs with large language models to enhance reasoning capabilities?
The proposed framework offers several specific advantages when it comes to integrating knowledge like graphs with large language models. First, knowledge graphs provide a structured way to represent facts about real-world entities and their relationships. So this is like having a well-organized library where every book of facts is in its right place, making it easier for the model to actually find and use the information it needs. This structure really helps the model to reason more effectively because it can refer to specific facts rather than just relying on patterns in text. Second, by using knowledge graphs, the framework enhances the model's robustness, which means it becomes stronger and less likely to make mistakes. It also improves auditability, allowing users to check and verify the information the model uses, similar to having a reliable index in a book that helps you find just the right chapters. Moreover, the framework focuses on factual consistency, ensuring that the information generated by the model really aligns with real-world facts. This is like making sure that a story you tell is based on true events, so it really remains trustworthy. Lastly, the framework aims to provide interpretable context extraction, which means that it can explain just how it arrived at a certain answer. This is really important because it helps users understand the reasoning behind the model's responses, making the interaction more transparent and trustworthy. In summary, by integrating knowledge graphs, this framework enhances the reasoning capabilities of large language models, making them more accurate, reliable, and easier to understand.
Can you explain the significance of the bidirectional feedback loop within the framework and how it actually influences the relationship between the knowledge retrieval module and the reasoning module?
The bidirectional feedback loop within the framework is like a conversation between two friends who are working together on a project. One friend is responsible for gathering information, the retrieval module, while the other is focused on reasoning through that information, the reasoning module. This collaboration is significant because it allows both parts to really improve and adapt based on their interaction. When the reasoning module processes information, it can identify what it needs to understand better. If it finds that the retrieved knowledge is missing important connections, it can actually signal the retrieval module to look for more relevant facts. This is similar to one friend saying, "I need more details about this topic," prompting the other to dig deeper. On the flip side, the retrieval module can also clarify what it needs based on the reasoning outcomes. If the reasoning module finds certain information irrelevant, it can let the retrieval module know, which helps filter out unnecessary data. This back and forth communication ensures that both modules are aligned and working towards the same goal, making the overall process more efficient. The cyclical nature of this interaction helps to create a dynamic system where both modules can adapt to really changing needs, rather than just following a set path, so they can adjust their actions based on the evolving context of the conversation. This kind of tight coupling between the reasoning and retrieval processes reduces the chances of losing important context and enhances the overall effectiveness of the framework. In summary, the bi-directional feedback loop is so crucial as it fosters collaboration, allows for continuous improvement, and ensures that both the reasoning and retrieval modules work together so seamlessly to provide better outcomes.
What methods or techniques are employed to ensure that the multi-step inference performed by the reasoning module is effective and leads to really reliable conclusions?
To ensure that the multi-step inference performed by the reasoning module is effective and leads to reliable conclusions. So several methods and techniques are employed. First, the reasoning process is so structured into an iterative series of inferential steps. So this is like following a recipe where each step builds upon the previous one, ensuring that nothing is skipped and that the final dish turns out well. The reasoning module guides the large language model LLM through this structured process, applying knowledge retrieved from external sources to fill in gaps and resolve any sort of uncertainties. Second, the reasoning module probably uses a self-discovery approach to determine the best way to structure its reasoning. So imagine a student figuring out the best way to solve a math problem by trying different methods until they find the most effective one. This allows the module to adapt its reasoning strategies based on the context and the specific problem it is really tackling. Third, at each step of the reasoning process, the module provides relevance like feedback. This means it evaluates the retrieved facts and filters out any sort of irrelevant or noisy information, much like a detective who sifts through clues, to focus only on the ones that really matter. This helps reduce confusion and just keeps the reasoning on track. Additionally, the reasoning module operates in a procedural manner, so focusing on the how of inference. It carefully confirms the validity of facts before using them and actively queries for more information if there are gaps in understanding like her. This is basically like a researcher who double-checks their sources and asks experts for clarification to ensure their conclusions are based on solid evidence. Finally, the cyclical collaboration between the reasoning and retrieval nodes allows for continuous improvement. So as the reasoning module processes information, it can communicate its needs back to the retrieval module, which can then provide additional relevant knowledge, creating a loop that enhances the overall reasoning process. So, in summary, these techniques structured multi-step reasoning like self-discovery of reasoning strategies, relevance feedback, procedural validation, and cyclical collaboration work together to ensure that the reasoning module can effectively derive reliable conclusions from the kind of knowledge it processes.
What kind of impact does the integration of external knowledge through this framework have on the overall robustness and auditability of large language models, particularly regarding their real-world applications?
The integration of external knowledge through this framework significantly enhances the robustness and auditability of large language models, especially in real-world applications like, first, by using knowledge graphs, the framework introduces dynamic and structured reasoning based on factual information rather than relying solely on free-form text. So, this structured approach actually makes the model more robust, meaning it can handle a wider variety of tasks and scenarios without breaking down. It's like building a sturdy bridge that can support heavy traffic rather than a flimsy one that collapses under pressure. So, second, the framework improves auditability, which is the ability to sort of track and verify the model's reasoning process. Since the system is broken down into cooperative agents with defined roles, it becomes easier to understand how decisions are actually made. This transparency is so crucial in real-world applications where accountability is important, such as in healthcare or finance. So if something goes wrong, users can analyze the communication between the agents to pinpoint exactly where the issue occurred, whether it was due to inadequate knowledge retrieval or just a reasoning error. This is similar to having a clear map of a journey, allowing you to see where a detour actually happened. Additionally, the framework allows the model to actively explore and update its knowledge base, so continuously.
Yeah.
This means that the model can adapt to new information and changing context, making it more reliable in dynamic environments like. So for example, in a customer service application, the model can incorporate the latest product information to provide accurate assistance. In summary, integrating external knowledge through this framework enhances the overall robustness of large language models by providing them with structured reasoning capabilities. It also increases auditability by making the reasoning process transparent and traceable, which is so essential for ensuring trust and reliability in real-world applications.
How does the framework address the issue of factual hallucination, commonly seen in large language models, and what sort of mechanisms are in place to ensure factual consistency in the generated outputs?
The framework addresses the issue of factual hallucination, which is when large language models generate confident but incorrect responses. So by leveraging knowledge graph, these graphs provide structured, so machine-readable facts about real-world entities and their relationship. This structure helps ground the model's reasoning in actual facts rather than just relying on patterns, like it learned during training. By using knowledge graphs, the framework enables dynamic and structured reasoning that is rooted in external facts. So this is like having a reliable encyclopedia that the model can refer to while answering questions, ensuring that the information it provides is accurate and relevant. Instead of just creatively recombining bits of information from its training data, the model can verify its responses against the concrete facts stored in the knowledge graph. To ensure factual consistency in the generated outputs, the framework incorporates mechanisms that contextualize and constrain the language models like responsive. So this means that the model is guided to use the facts from the knowledge graph as a foundation for its reasoning, reducing the chances of generating false or misleading information. In summary, so by integrating knowledge graphs, the framework effectively mitigates the problem of factual hallucination. So it provides a solid grounding in real-world facts, ensuring that the outputs generated by the model are not only fluent, but also factually consistent and reliable.
So what are the potential implications of this knowledge graph reasoning framework for future developments in artificial intelligence, particularly in terms of enhancing user trust and the ethical use of AI technologies?
The knowledge graph reasoning framework has several potential implications for future developments in artificial intelligence, particularly in enhancing user trust and promoting the ethical use of AI technologies. So first, by providing interpretable and trustworthy context extraction, the framework allows users to see how the AI actually arrives at its conclusions. This transparency is so crucial for building trust, as users can understand the reasoning behind the AI's responses rather than viewing it as a mysterious black box. When users can trace the logic and verify the facts used in the reasoning process, they are more likely to trust the AI's outputs. Second, the framework's reliance on structured knowledge from knowledge graphs really helps ensure that the information provided by the AI is factually accurate and grounded in real-world data. This reduces the risk of misinformation, which is essential for ethical AI use. So when AI systems produce reliable and consistent outputs, they can be more confidently integrated into sensitive areas such as healthcare, finance, and education, where accuracy is sort of paramount. Moreover, the framework incorporates mechanisms for relevance feedback, allowing the system to continuously learn and adapt based on user interactions. So this adaptability means that the AI can improve over time, becoming more aligned with user needs and preferences, while maintaining ethical standards in its responses. Lastly, by optimizing the search for knowledge through techniques like beam search and adding constraints, the framework can provide more precise and contextually relevant information. This precision can help prevent the misuse of AI technologies, so as it encourages responsible and informed decision-making. In summary, the knowledge graph reasoning framework has the potential to enhance user trust by promoting transparency, ensuring factual accuracy, and supporting ethical AI practices. So these improvements can lead to more responsible and effective applications of AI technologies in various fields.
So thank you for joining us for what has been a truly illuminating discussion. Our conversation today has clearly laid out the kind of inherent strengths and challenges of large language models. While they excel at generating incredibly fluent text, we've seen how their lack of true understanding can lead to struggles with complex reasoning and factual accuracy. To address these very real limitations, so we delved into an innovative framework that integrates knowledge graphs. This powerful approach enhances capabilities by providing structured factual information, effectively giving these models a really solid foundation for more reliable reasoning. A key takeaway is the dynamic interaction facilitated by a bi-directional feedback loop between knowledge retrieval and reasoning modules. So this continuous iterative process is what truly elevates the system, fostering greater robustness, improving auditability, and significantly boosting factual consistency. The result is just a substantial reduction in issues like factual hallucination. This enhanced transparency is so paramount. It builds user trust and strongly supports the ethical development and deployment of artificial intelligence, ensuring that outputs are both accurate and sort of relevant. So this makes such frameworks particularly well suited for critical applications in sectors like healthcare and finance. And ultimately, this approach represents a significant step forward in promoting responsible AI development and ensuring these powerful tools are genuinely so effective and trustworthy in real-world applications. A huge thank you to our expert for sharing such profound insights and to all of you for just tuning in. We hope this discussion has provided a deeper understanding of the really exciting advancements shaping the future of AI. So join us next time for another exploration into the frontiers of technology.